Good afternoon, everyone. My name is George Ann Moss, and I'm the Executive Administrator of Sustainability Outreach and Initiatives for Dallas College. And welcome to this next episode in the Sustainable You series. And so for those of you who have not joined us before, I'll give you just a couple of housekeeping items. The first is there are two ways to communicate with us. One is through the chat, and the other is through the Q&A feature. And so if you want to just make comments about the presentation as we go along, you can make those in chat. But if you actually have a question that you'd like an answer for, it works best if you put it in the Q&A, because then we can answer specific questions. There will be an evaluation that pops up at the end of this session, and we ask that you take just a couple of minutes to fill that out for us, because we are continually trying to improve these sessions, and your feedback helps a lot, so we appreciate that. And today, in addition to our speaker, we have several team members from the Sustainability Department at Dallas College working behind the scenes to staff the chat and the Q&A and all that. Sonia Ford, Lori Dela Cruz Lewis, and today we have with us our Dallas College's energy manager, Garrett Rosser, and he is going to be the host and the moderator for this session. So I'll turn it over to you, Garrett.
Great, looking forward to it. We are pleased to have with us today Marc Clinch, Chief Facilities Officer with the School District of Osceola County, Florida. Marc has a unique and valuable perspective on the built environment. He has been heavily involved in the definition of design criteria for high-performing buildings and their implementation within Osceola County schools, and he's responsible for the long-term maintenance and operations of these facilities. Marc has a strong background in construction and building science. He's been working in the public sector for more than 15 years. As Dallas College continues to seek ways to fulfill our obligation to reduce energy use and costs, and as we continue planning discussions for future buildings and college locations, it's great to find a resource like Marc, who's so willing and ready to provide so much practical advice on high-performance buildings. So Marc, we welcome you today, and we look forward to your presentation, and we thank you for being here.
Well, thank you, Georgianne and Garrett, and for Dallas College for hosting the presentation today. Today's presentation is about reducing operational costs with high-performance school buildings. The school building that is pictured is the Neo City Academy. It is a STEM high school, and we'll be talking about it further in our case studies. But what I want to point out is that this project started as a high-performance building. Now, we were able to get the building to a full net zero energy, as you can see from the solar panels. We're at net positive, but we were only able to do that because of starting with high performance and driving down that energy use intensity. So for all intents and purposes, what I really want to amplify today is that high performance is about that ultra low energy usage, getting that EUI as low as possible. My other disclaimer is that I am not a salesman. I am not here to sell you on anything today. However, I am here today to share golden nuggets of information that I think that you can take back to your organizations and utilize. I truly want to see you be successful with high performance building criteria. Why? School districts spend over $6 billion a year on power costs. That is the highest operational cost, second only to salaries. And that's not just schools, that's any organization. We really need to think about the cost of ownership as we build our buildings. So what we'll talk about today is what is a high performance building, the why, the cost premiums and ROIs. I'll share several case studies, terminology, and I will take three out of this, or at least I hope to. I'll share mock-ups and testing, recommended next steps, and then we'll open up for Q&A. So this is a prototype building. Both of these are prototypes, the top and the bottom. The top was built to traditional standards and the bottom to high performance. So what this illustrates is that you can take a prototype design and tweak it or fine tune it to get it to a high performance building criteria. Now, high performance buildings will save you 65 to 80%. That's a significant operational savings. And here at our school district, that's huge, because that allows us to move those dollars elsewhere where we have tremendous need. Why? U.S. energy use. Buildings consume over 40% of that power in the United States. Osceola schools, our utility costs alone are 90% of that, 90% with our utility costs. That is a big number. So it's not about first costs. It's really about life cycle costs. It's not about building things as cheaply as possible. This does involve some upfront, minimal premiums, quick return on investment. But this slide summarizes that life cycle cost analysis from the City Academy project. As you can see, we're saving $115,000 a year. And granted, this is for a building that's less than 45,000 square feet, $115,000 a year in operational savings. Over 20 years, when you factor in the maintenance costs, that's over $3.2 million. And we were able to build to high performance, achieve all the criteria set by our Department of Education here in the state of Florida. We achieve all our state requirements for educational facilities. We comply with our cost per student station, which is governed by Florida statute. So here is our first case study. Again, Neo City Academy, and building this project to a high performance building criteria. That was a 5.2% premium, a ROI of less than 5 years. Now, ladies and gentlemen, I've been doing life cycle cost analysis for my entire career with school districts. And I can tell you that in my past experiences, anything that was 5 years or less is what we called a no-brainer. Why? Because school buildings are going to be there for a long time, for 40 or 50 years or longer. So if we can save operational costs, in this case, $115,000 a year, year after year for the life of this building, that really is something to talk about. So to take the same project to a full net zero energy, and as I mentioned, we're actually net positive, but to take the building to net zero energy, that was a 9.1% premium, and the ROI, 7.5 years. Again, really not bad for what we were able to achieve. And again, this is the first zero energy school in the state of Florida. Our next up, so Neo City Academy, the high performance, 77% of our savings. The solar component represents the remaining 23% of our savings. So what I really want to amplify in this slide is that high performance is the cake. It's the big piece, whereas the solar is the icing on the cake. So the tremendous savings that comes from high performance before putting the first solar panel on your building to achieve these incredible operational savings. So here's our next case study. And in fact, this building this project was just selected by the Building Central Florida as the feature project for the month of February, and is our Osceola Business Academy. To get this building to a high performance building criteria, it was a 1%. It was actually just a little under 1%. And the ROI, 5.3 years. Really not bad for the minimal premiums and the return on investment. And granted, this building is less than 27,000 square feet and will save over $14,000 a year. Now, what we're doing is going through our 1-year run period. We're gathering our data now. So I suspect that as that data comes in, we'll see those savings exceed the 14,000 a year. And you know, and this is the case with other previous projects that we've completed, where we monitor our operational costs for the first year to ensure that the project is achieving our objectives. And we are finding that we are routinely exceeding the criteria set for these buildings. Our next case study, this is a K-8 that is currently in construction. Full-blown K-8 has a kitchen cafeteria, media center, admin suite, classrooms, gymnasium. So this building is being built to high performance, 1.5% premium, and a ROI projected of less than 3 years, and will save us a projected $125,000 a year. Again, as we commission this project and are able to gather that run data for the first year, I suspect that our operational savings will actually improve, will actually be better, higher than the $125,000 that is currently being projected. And that project is scheduled for completion this summer. So high performance versus zero energy. I've used both terms. I want to make sure that there's a clear understanding. High performance is that ultra low energy usage. It is before installing the first solar panel. It's about driving down that energy use intensity. Whereas zero energy is now adding that renewable energy component. So that can be broken down into net zero or net positive energy. So it's that final push to get that building to an ultra low energy usage, and then adding the solar component to get the building to zero energy. My presentation today is not to advocate for zero energy. It's really to advocate for high performance, because again, that is where the majority of the savings occur, is with the high performance component. So here are some components, and this is not an all-inclusive list of high performance. There's energy modeling, right-sizing the HVAC system, high performance windows and doors, cool reflective roofing. These are all strategies of high performance, and there are several others. This is an example, a sampling of some of those strategies that are incorporated into a high performance. The differentiation I want to make here is the difference from high performance to zero energy, again, is the addition of the solar array. It's that final push to address that remaining EUI. So keep in mind, high performance, driving down the energy use intensity as low as possible, and with that small remaining EUI, then adding the solar component to get to zero energy, whether that's net zero or net positive energy. And here is an example of one of the things that's done to tighten up that building envelope. What is circled in red is the way that we have always built buildings. And this example is from Tilt Up Construction, where we have installed the backer rod and the caulk joint. And ladies and gentlemen, I can't tell you how many times I've walked a school project 2 or 3 years after completion and have seen where this caulk joint is failing. That means the building is leaking. So with high performance, to get to a tight building envelope, it is a belt and suspenders approach. So rather than doing the one caulk joint, we're doing 4 to 5 additional applications to ensure that the building will remain tight over the life of the building. The pictures show our quality control plan, where contractors coming on site could see what each progressive step needed to look like. So before proceeding to step 4, they could see what step 3 needed to look like to ensure that we were getting the best possible product with getting our building as tight as possible. So, you know, high performance, it's getting to the Yeti cooler And I'm not going to say that it is the Yeti cooler, but it's that attention to detail to get the building as tight as possible. Now, and also keeping things reasonable, keeping your cost in line. You know, there are many more things that we could be doing to our buildings to get them even tighter, but this is where our cost model works the best, to tighten that building envelope and to reduce that mechanical footprint to drive down the energy use intensity. So in addition to the other benefits of high performance, in addition to ultra low energy usage, there are some other obvious benefits to high performance buildings. You know, one of those is a DOAS, which is a dedicated outdoor air system. Rather than recycling air, which most of our mechanical systems do, we are actually able to bring in 100% outside air. We scrub it, we clean it, temper it, and able to get fresh air circulating in our building. Also, we're able to maintain our CO2 levels. The Harvard study was a study to subject pilots to high levels of CO2. They were subjected to 2,500 parts per million, and what they found is that those pilots could not perform basic maneuvers. So by lowering our CO2 to levels between 700 and 1,000 parts per million, we're actually doing good things to enhance student performance in our school. And ultimately, that's the business that we're in, to educate our students. So why not provide the best atmosphere possible? Another attribute of high performance is natural daylighting. Studies reveal lots of good things, better test scores, better regulation of hormones, and just having that natural daylighting does create significant benefits all the way around. So in addition to the benefits of high performance, those typical strategies, these strategies provide further synergy. What is EUI? Energy use intensity. This is everything in the building that consumes power divided by square footage. As simple as that. It's like a golf score. A lower score is better. We want to get that EUI as low as possible. Here are comparable EUIs. So the national average is 68 EUI. In our school district, 65. We're slightly higher than the average for our state. One of the reasons why we are driving our high performance goals as heavily as we are. With Neo City Academy, we were able to get that EUI down to 16. Now our target, our criteria that we set for that project was 20. And as I stated earlier, we have been historically exceeding the criteria that we've established with our EUI and with our air leakage. But a low 16 EUI as compared to the 20, the criteria that we set. With the Osceola Business Academy, the criteria we set for this project was 25, and we've actually been able to achieve 22. Criteria for Canoe Creek. The criteria that we set for this project that is currently under construction is 25, but I suspect that as we test out, we will see an EUI lower than that 25. And the criteria that we set in our school district is an EUI of 25 with an air leakage rate of 0.20 cubic feet per minute per square foot. This criteria is very achievable. It is not that tough. So it's all about minimizing the air leakage, right-sizing the mechanical system, ultimately reducing that energy footprint. This is the voice of your father telling you to shut the door. I'm not paying to cool the outside. But essentially, this is what we do every day in our buildings. Our buildings are leaky. the major source of that energy loss is because of air leakage. So by tightening the building envelope and then right sizing the mechanical will get us to that reduced energy footprint. And why is it tough? It's shifting that paradigm, that mindset. It's those contractors and designers that will tell you, well, the reason why I'm doing it this way is because this is the way that I've always done it. It needs to start with shifting that mindset, getting designers to understand these simple strategies that can significantly improve the performance of our buildings. There are, many designers and construction managers that I've talked to that we work with that have been very receptive to this approach. There are some that have not been. It's really shifting that mindset because people typically want to keep doing what they've always done. Not to say that the way that we built buildings in the past is incorrect, but there is a better way to do this, a much more improved way of significantly lowering your operational cost. So this is the mock-up that we utilized for Neo City Academy. This provided tremendous lessons learned. One story I like to tell is when the window contractor showed up to install the window for the mock-up, he had installed the window like he always had. Well, when we pressurized the mock-up and we subjected it to smoke to see where it might be leaking, we found 3 locations in that window where smoke was escaping from the mock-up. It wasn't billowing out, but it was very prevalent that we had air leakage in those 3 locations. So we worked with the window subcontractor to get that subcontractor to understand the expectations and objectives for our project. So when the windows were ultimately installed at the actual building, there was great attention to detail to ensure that those windows were sealed. Mock-ups are the dress rehearsal for the big performance, and that big performance is the building. There are so many things that we learned from our mock-up at Neo City Academy, that first mock-up, and it was invaluable. And all those lessons learned were incorporated into the actual building. Here is the mock-up from the Osceola Business Academy to the left. Now, in this case, there was no throwaway costs because we were able to use this building as the new security checkpoint for the high school where our Osceola Business Academy is located. The photo to the top right shows the blower door test. This is the air leakage test, which tests both for infiltration and exfiltration. And as I mentioned previously, the criteria we set for this project was 0.20. What we actually achieved was 0.032, 80% better than the criteria that we set. And this is what contributed to allowing the energy use intensity, that 25, to reduce down to a 22. So this does contribute to that EUI. The bottom right is another photo of the mock-up at Neo City Academy. And you can see that is the window that I referred to previously. In addition to the air pressure testing, we also did the 501.1 water penetration test. This simulates water hitting the building at 150 miles per hour. So we are not continuing to do that on our subsequent projects. We feel that with the air leakage testing, that this is satisfying our requirements, giving us a good comfort level that we're getting to an airtight envelope. However, if you have a building located in a coastal area, this is something you may want to consider. We're now using the 501.2 water penetration test for our mock-up, and that is providing us some good results, some good information, good lessons learned as we're moving forward with the ultimate building of our projects. So with Neo City Academy, this example shows that if we would have got to the 0.15 cubic foot per minute, we would have been just under 11,000 cubic feet per minute. Well, this compared to if we would have built this building to the current energy code or the energy code at that time, we would have had to design in another nearly 28 tons of chiller capacity. So this is like a 28-ton chiller sitting in the parking lot, blowing cold air, doing absolutely nothing for us. So we were able to reduce our tonnage by 28 tons. So it just goes to show, this is a great example, that when you that building envelope, you now have the opportunity to right size, to downsize your mechanical systems. So what we actually achieved was a air leakage testing of 0.027, 82% better than the criteria, that 0.15%, or 0.15 cubic foot per minute per square foot that we had set for the project. Less than 2,000 cubic feet per minute. And again, ladies and gentlemen, this is very achievable. It requires attention to detail, but it starts with shifting that paradigm with your designers and construction managers. So design RFQ recommendations moving forward. What we did is we included this narrative in our RFQs. This is all we did in our design RFQ. We simply stated that we wanted the architectural firm to prepare design documents for the construction of a high-performance, zero-energy project. Now, zero energy means that we wanted the design to incorporate all the infrastructure, the empty conduits from the roof down to the electrical room, space provisions in the electrical room, so that if we ultimately took this building to zero energy, which we did, that we would have all that built in. We wouldn't be going in after the fact and drilling holes in our nice tight building envelope. The other criteria is to set a maximum energy use intensity. I recommend 25. Now, when we started our first project, Neo City Academy, that criteria was 20. So as you can see, we have since loosened it up. The difference with our first project, we had a seasoned designer and construction manager that had done high performance. But now we have subsequent firms on subsequent projects that have little or no high performance experience. So we wanted to loosen up the criteria just a little bit to ensure that this was achievable for those firms that had little or no high performance experience. And again, with our case studies, we have been successful. Ladies and gentlemen, we're doing this project after project. It is not that difficult. And the maximum air leakage I would recommend is 0.20 cubic foot per minute per square foot. As I mentioned, we have been exceeding this criteria as well. We've been getting anywhere from 0.027 to 0.046 has been our worst reading on all our blower door air leakage tests thus far. So that 0.2 is something that's very achievable. What about renovations? I'm often asked, well, what's the premium to incorporate high performance renovation? Well, the simple answer is it varies. It depends on the extent of the renovation. Is it a renovation where you're exposing the outside envelope and you have opportunities to improve, to tighten that building envelope? Or is it simply an HVAC renovation project where perhaps you're pulling out ceilings and lighting, putting in new ductwork, VAV boxes, etc., installing new ceilings, and now you have the opportunity to install LED lighting? It depends on the extent of the renovation. However, to whatever extent of a renovation that you're planning, high performance strategies are entirely possible to incorporate into your project. It starts with benchmarking. Have your designer, your mechanical engineer, determine the EUI for your current buildings, and you should be able to get this from your energy manager in your organization, and perform an air leakage test so that you can truly tell the dollars where to go in that renovation, so that you can maximize getting that bang for your buck with the renovation. I'm a believer of commissioning and retro commissioning. Commissioning is the verification to ensure the owner's project requirements are being incorporated. Just because there is a design that tells a mechanical contractor and a controls contractor what to do doesn't necessarily mean that it will happen. It requires a third party to come in and do that commissioning to trust but verify that these OPR requirements are being achieved. It's a quick return on investment to ensure that the design intent is being achieved. And then also with retro commissioning of existing facilities, just like a car that requires a tune-up every 5 to 8 years, buildings are different. They get out of tune. They get out of whack. Mechanical people, mechanical personnel going into those mechanical rooms, implementing overrides. And so this is a way to identify overrides and other abnormalities to get that building back to the original expectations for the operation. Other considerations, as I mentioned previously, for that first, I would really consider selecting a designer that has a successful track record with high performance. That's what we did, and that's what really got the momentum going for us. That first project was critical to really establish that path forward for our school district. However, on our subsequent projects, we are moving forward with designers and construction managers with little or no high performance experience. We are pulling them to the finish line to ensure that we're moving those barriers, that they understand our objectives, and that we're truly working with them for them to be successful. Again, this is about minimal cost premiums, a quick return on investment, so that you can ultimately reduce those operational costs and have better performing buildings, buildings that have better air quality, buildings that can be used as a teaching tool in the case of school districts. We actually energy dashboard on our Neo City Academy where students utilize the dashboard routinely to complete classroom assignments. They can see what the production is versus the consumption is doing at that school. They can virtually go onto the roof and in the mechanical rooms to see how that school is functioning so that they can learn about what it takes for a building to operate. And, healthier buildings. I didn't mention earlier that DOAS, that dedicated outdoor air system. In our post-COVID world, ASHRAE has determined that a DOAS system as their #1 recommendation for owners moving forward with building projects to incorporate a DOAS, a dedicated outdoor air system. So, this was prior to COVID. So we were, kind of ahead of our time in doing this, and and to see, this recommendation come from ASHRAE, that was huge. And ultimately, high performance paves the way for solar, so that if you, sometime in the future or immediately, if you want to get that building to a full zero energy, you have the ability to do so. But again, if you don't install the first solar panel on that building, you will achieve 65 to 80% cost saving just by tightening that building envelope, right sizing the mechanical, and incorporating those other high performance strategies. I call this slide the unintended consequence. This is from Neo City Academy, lots of awards and recognition. This was not our objective for Neo City Academy. We never intended for all this, these awards and recognition. We've received 11 prestigious awards, one of which is our local Contractors Association Project of the Year, the AIA Project of the Year for Central Florida. And we've been published 19 times. So we have received lots of attention for this project. And now those awards and recognition are starting for the project, the last high performance that we completed, the Osceola Business Academy. As I mentioned, it's been published in the Building Central Florida magazine. This is the third time that we are published on that project. So it's not about the awards and recognition, but it does confirm that you're on the right track. And I can tell you, one of these very prestigious awards, we're up against 3 other projects. One of those projects was nearly $300 million. The other 2 projects were nearly $250 million. And we thought, surely, how our little old $11.3 million project stack up against those giants? Well, it turns out that when you do something good, something unique, something different, people stand up and take attention. Ladies and gentlemen, you can do this. With that, I will open it up for questions.
So, Mark, this is Georgianne. I see a question in the chat that says, how do we go about updating all our old buildings to maximize them for better operational costs? So it's a clear path if you're starting with new buildings, but how do you do that for existing buildings?
Yes, wonderful question. So it is easier to incorporate high performance during the initial construction of a building. But as I mentioned, there are some real benefits to incorporate high performance strategies in renovations as well. Now, again, it depends on the extent of the renovation as to the extent of the high performance strategies that you can incorporate, but start with benchmarking that existing building. Determine what the energy use intensity is for that building. Perhaps it's currently at a 65 or a 68 EUI, and charge your design team. What will it take to get this building down to, say, a 30 or a 35 EUI? And even if you're not exposing, it's not a complete gut of that building where you're exposing the building envelope, where you have an opportunity to now tighten the building joinery, the wall connections, the floor wall, the wall to ceiling connections. You have opportunities. It may be, properly placing insulation, radiant barriers, right sizing the mechanical system. If it's a mechanical renovation, installing efficient mechanical system, and I'm refraining from using the term highly efficient mechanical, because you really need to look at the payback for your mechanical. Mechanical equipment has an average life expectancy of 15 years. If you're installing that highly efficient mechanical and you see that ROI is 18 years, that's not a good investment, because likely that mechanical equipment will fail at 15 years or less. But do something maybe less efficient, but it's about the trade-offs, looking at your life cycle cost and really telling those dollars where to go in that renovation so that you can achieve the best results and benefits from that renovation.
Thank you. I believe Garrett has a question for you also.
Sure. Yeah, I think just from our perspective, as we start looking at new construction projects that we've got going on, and some of this is regional, of course, but what are the approximate cost per square foot of your high performance buildings? Do you have a good round number, I guess?
Yeah, for our school buildings, we've been running anywhere from $180 to $200 a square foot. As compared to our traditional construction, it's running anywhere from 180 to 220. And, now, as I mentioned, there are premiums in high performance, but it's more, you really need to look at the premium and from studies, and those premiums have been somewhere around 5%. And it's a great question, Garrett, in that there are some designers that you will talk to that will tell you, Mr. Owner, oh my God, this is going to be another 2 to 3 million to get this building to high performance. And you're probably not talking to the right people, because again, this is about minimal premiums, incorporating low cost, low tech solutions to significantly enhance the operation of your buildings.
Very good, thank you. And another one I was curious about is, as you were going through the vetting process for that first partner on that first high performance project, a little bit of uncharted territory. How difficult was it to find the right partner for that? What was the process like for that? How many rounds of interviews, and just the nuts and bolts of that process. And I guess, who did you have involved in that evaluation committee? Was it the normal crew, facilities folks, or did you have some stakeholders from across the organization?
Yes, we had both. So the way our selection process works, for anything that is 2 million or more, we have to follow the CCNA, Competitive Contractor Negotiation Act. And that requires that we go through a shortlisting. So various firms submit RFPs, and I believe on the Neo City Academy project, the project you're referring to, we had 14 submissions, and we shortlisted 3 firms. So we had those 3 firms present. They did oral presentations, and we had a committee, school district committee, selection committee of 7 personnel, of which 3 were from the facilities department, and those others were from school operations and other areas, curriculum, various areas, various stakeholders within our school district, so that we could get a good cross section of, different people come to selection committees with other things, different things being important to them. But I can tell you that, we made it very clear that when we put the RFQ out, and that basic language that I recommended in the presentation, that's what we included in our design RFQ language in the narrative. And that's really all it took to bring lots of firms to us that had high performance, zero energy experience. And I can tell you, all 3 firms that were shortlisted, all 3 of them had high performance, zero energy experience. But when we got to the presentations, it was very clear who rose to the top and who was ultimately selected. A firm that was very seasoned with high performance, zero energy. They provided, their life cycle cost analysis, cost exhibits, and that type of thing, and the strategies, how they were going to incorporate this into this project.
This is Georgianne again. I've had a couple of questions come in privately to the host. And so the first one is, can you provide a link or reference for explanation of DOAS and how they help with energy efficiency?
Yes, happy to do that. Georgianne and Garrett, I can provide that to you. And it will be a link that will come from ASHRAE, from the American Society Heating, refrigeration and air conditioning, the authority that oversees everything that is air conditioning and HVAC. Happy to do that.
Wonderful. And then here's a question, and it's a question about Texas. So since you're from Florida, you may not know the answer to this, and that's perfectly okay. But the question is regarding air source heat pump mini split systems and ground source heat pump systems in Texas. So I think the question is saying, do you have any comments about one or the other, or how those compare? And you can tell us how they compare in Florida if you'd like that.
Yeah, actually, we use them extensively in Florida. I love mini splits, but each has a different application. You know, the mini splits are great. IDF and MDF, those are our communication rooms, the main distribution facility and the intermediate distribution facility for all our systems, our technology. And the mini splits are great because they operate, number one, very efficiently. Number two, most power companies provide rebates for mini splits. And number three, they're very simple to, install those components in our communications rooms. The heat sourced, the heat pumps, those are great too. We use those extensively, but again, it's about your design team vetting through all the different options and coming up with the best option for your project. I can tell you for our Neo City Academy, we did we have a cooling tower, a water cooling tower. But in our other schools, we have air-cooled chillers. So it all depends on, what is going to work best. Let your design team vet through that and let them come up with the trade-offs too. We had looked at a high-performing window system that would have been $11,000 added to the project costs for this high-performing window. And the trade-off is we were able to, add $3,000 to our solar to achieve the same results. So it's all about the trade-offs and having your design team vetting through what is the best technology for that particular project.
Thank you. Lori or Andy, did you guys have any questions to bring forward?
There was a follow-up question to that specifically. Are these technologies available for any existing building?
Yes, absolutely. Again, it depends on the extent of the renovation. If you're doing an HVAC renovation project and it is limited to that, great opportunity to incorporate the mini splits and the heat pump type technology.
Another question came in. What additional measures do you consider for providing the cleanest and most efficient power usage for your electrical and mechanical systems to improve life cycle costing?
Okay, so in my previous school district, 7 years ago, we were doing separate home runs for clean power, and this was exclusively for computers. However, now we are seeing that our computer systems are much hardier than they were. They're not as sensitive and as prone to various power surges. So we no longer incorporate a separate distribution system for clean power. It is all the same distribution system. For the most part, our power sources are very reliable here in Florida, and I would suspect that that's probably similar in Texas. But we are not, to answer the question, we are not doing anything specific to address clean power.
And then there was a follow-up to that question. What percentage reduction was the size for the solar array after the building envelope was tightened?
You know, I'm sorry, I don't have a specific percentage, but again, for us, you know, the gauge that we use is energy use intensity. So that if you're getting that building down to a 20 EUI, then installing a solar system that would provide that corresponding power to get that 20 EUI to zero. I'm sorry, I don't have a specific percentage.
We have one question that came in about through the chat. Do we know the firms that are best at high performing design in Dallas? And that's something that we can take that discussion offline. You know, certainly there are a number, and we can't endorse any one of them, but we can talk to you about who we know works in that space in Dallas.
Yeah, there are no specific, I know in the state of Florida, no specific Florida statutes that incentivize people to go high performance yet. I think that's coming, but there are various Florida statutes that encourage energy consumption and energy reduction. But look, this is a trend that's growing. And I've been studying high performance zero energy for, since 2012. And I remember in those first case studies, one of those is Lady Bird Johnson Middle School in Irvine, Texas, right in your backyard. It was one of the first zero energy schools. It started as high performance, but it was zero energy. And what I saw with that school is the costs were about 30% higher than what we were constructing at the time as far as middle schools. And, from that's what first excited me, one of those projects that first excited me about high performance zero energy. And I thought, there has to be a way to do this with minimal premiums, much less than that 30%. And, now we're seeing premiums 5% or less. So it proves that there is a way to do this. Now granted, Lady Bird Johnson was one of the earlier models, very, very interesting, great product, but technology has evolved since then. It's gotten better. Solar production has gotten better, and we know more about it now. And that's the big thing, is the knowledge that we have about high performance. And that's really what has helped to demystify this, because in 2012, high performance zero energy was just such a mystery to me. And, as I dug into it and peeled back the layers of the onion, I found that it's really not that mysterious. It's really about starting with that proper mindset, number one. And number two, looking at the attention to detail to tighten your building envelope and drive down that energy use intensity. And you'll see with organizations like the New Building Institute, where the trend is growing very rapidly. So today, high performance is a niche service that's offered by a handful of designers and construction managers. But in the very near future, this is going to be mainstream. It's this is how we keep up with our energy demands in this country. There is no silver bullet, but ladies and gentlemen, I'll tell you, high performance is something that is directly positioned very well for us to take advantage of that opportunity. This is a huge opportunity.
Some other questions came into the Q&A. Any thoughts on smart building or distributed energy resource management systems, including bells and whistles like storage, peak shaving, electrical vehicles, V1G and V2G, or other thoughts? Yeah,
absolutely. It's coming. The smart technology continues to become more prevalent, more readily available for purchase. And, I'll tell you, with Neo City Academy, we looked at battery storage, for example, and we found that at the time that the technology just wasn't there yet, but it's coming. The smart technology, battery technology, battery storage, it is continuing to improve, and it's we're gonna be seeing these things coming into the marketplace at a very reasonable price, kind of like LED lighting. 10 years ago, it was very expensive, and we didn't do it because of the cost. But now, LED lighting is a no-brainer. So like LED lighting, that smart technology, the availability, the pricing, it's coming.
And then could you share a link or resources to information about these technologies for existing buildings?
Yes, let me see what I can pull together, and I'll forward that to Georgianne and Garrett.
And I think there's one more question about what technologies have you found to be the most effective and least obtrusive for lighting systems? Auto dimming, with daylight, motion sensors, others.
Definitely occupancy sensors. Occupancy sensors are very inexpensive. They're very easy to incorporate into the electrical distribution system, and they're foolproof. When people leave the room, the lights go out. There's, there are no variables with it. The lights are on or they're off. And also, with most new construction, most power companies will provide a rebate for occupancy sensors as well.
Wonderful. So Lori and Andy, one last chance for questions for Mark. Okay, it sounds like you have answered everyone's questions, and when you send those links to us, we will share them with the folks who were on this webinar. Garrett, did you have anything you wanted to say?
No, just thank you again, Mark. I know in the past we have heard and been exposed to folks that are really involved only on the design side and not necessarily implementing buildings and living with these buildings day to day. So it's great to have your perspective and know that you are the steward of these buildings that you helped inform folks on creating, and that they're serving the students there in Osceola County. So thank you very much.
Thank you. It was my pleasure to present today, and my contact information is on screen. Please don't hesitate to reach out to me if you have any questions. It would be my pleasure and honor to assist anyone that's interested in high performance.